Welcome. In this video, I'm going to be telling you about the law of sines, which is a nice little trick we can use to solve some trigonometry problems. But I'm going to start you off with the intuition here. Suppose we've got two sides of a triangle that are 3 and 4, and kind of the variable here is how far the angle between those sides is opening. Yeah, I think you know, like within reason, that the wider that angle opens, the bigger the other side is, right? For this theta 1 right here, this is kind of implying this side length. And for a larger value of theta, theta 2, we get more side that's across from a bigger angle. And I think that's pretty intuitive, but we're going to kind of be more formal about that relationship. Okay, now the relevant theorem here is the law of sines. And what it says is that the sine of A divided by A is the same as sine of B divided by B is equal to sine of C divided by C. Because if you actually went and measured, adding 1 degree does not add a set amount to the side length across from it. It really depends on the relative lengths of the other ones, and something about how far open the angle is in the first place. Okay, so this is the law, and I'm not going to prove this for you in this video. If you're interested in the proof, though, I have it proved in a different video, and you could probably click right up here or so to be taken to the proof of the law of sines. And what I'd say is that it's right at your level, right? It's definitely not too difficult for you to understand with the trig facts that you have right now. What I do want to do in this video is just, get in there and work some examples. All right, so we've got these triangles, and I don't know if you can see them all that well. It didn't print well on my notes either in class. But we've got 33 degrees and 67 degrees with 5 across from the 33. Okay, and we might be interested in finding, the length of side B. And what we're going to do, we're going to use the law of sines. Okay, so we're just going to set up for the law of sines. We're going to say, all right, sine of an angle divided by the side length across from it is going to be always constant. So sine of 33 degrees divided by 5, the side across from it, that's going to be equal to sine of 67 degrees divided by the angle across from it, which is b. Okay, now I can solve for b, algebraically cross multiply, so b times the sine of 33 degrees. That's going to equal 5 times the sine of 67 degrees. But I really think that you should try to just solve algebraically and only use the calculator once. Okay, so we're going to say b is going to equal 5 times the sine of 67 degrees divided by the sine of 33 degrees. And unfortunately, there's not any way we can simplify that before going to the calculator. But we'll go in here, bring in a calculator. Okay, I'm still going from the last lesson. Okay, I'm going to say bring in a fraction mark, right? Just write it exactly how you see it. 5 times the sine of 67 degrees, make sure we're in degree mode, which we are, divide by sine of 33 degrees. We'll get 8.451. Okay, and that's really the most basic case of us using the law of sines. So why don't you try this one on your own? I'm going to zoom in on the second case and let you work on that. Right, there we go. We've got 29 degrees across from a side length of 9 and 114 degrees, and we might be interested in the length of side A. So try this on your own. Just exact same as the one I just did. Make sure you know what you're doing. And you can check your answer against mine, which is going to pop up in just a couple of seconds. All right, there you go. So I did the same thing, set up law of sines, sine A over A equals sine B over B, or I guess in this case, sine A over A equals sine C over C. And I cross multiplied, solved for A, ran it to the calculator, got myself an answer. That's law of sines. Another way we could use the law of sines is to find a missing angle measure. So if we've got 47 and the 47 degrees for angle B and the length of the side across from it, and we've got another side, well, we could find the measure of the missing angle. We can find angle C. So we know that sine A over A equals sine B over B equals sine C over C. So what I'll say is that sine of 47 degrees divided by 6 is going to equal the sine of C divided by 7. And C is the thing that we're solving for here. And so we're going to cross multiply 7 sine of 47 degrees equals 6 times the sine of C. And then I'll divide both sides by c. And I'll say that 7/6 of the sine of 47 degrees, well, that's going to equal sine of c. If I want to solve for c, now I need to take inverse side of both sides of this equation. Inverse sine of both sides of this equation. I'm going to say c equals inverse sine or arc sine of 7/6 of the sine of 47. Okay, and that's something I can run through the calculator. You can find 7/6 of the sine of 47 first if you want. Actually, it's the exact same thing. We go to the calculator, type it in just like you see it, let it go, and say that's going to be 58.566 degrees. Okay, what I would point out is that if you know, measure of angle B and measure of angle C, now we could find measure of angle A, and then we could use the law of sines again to find the length of that third side. Okay, so the law of sines is opening some stuff up for us. But before I move on, I do want to point out that this is stuff that's kind of already been open to us. This is kind of just a shortcut, or not even a shortcut, I'd say just like a generalization, right? Because what we could have done here is just like cut it in half, or not cut it in half, but cut down with an altitude, suppose that was perpendicular, then we could have just done some old-fashioned trigonometry, kind of the way we did in the last video. So it's not like anything we couldn't do before, but just a better way. Okay, now the last example I've got for you is just kind of something a little bit different. It's telling you UVW is an isosceles triangle with a base of 425 feet. All right, so isosceles triangle, it's got two legs that have the same length and then kind of a base. Up to my ability to draw that. So if we're saying the base is 425 feet, we're interested in what are the others if the two legs meet at an angle of 39. Okay, so that's going to be the 39-degree angle. I could have drawn that a little better. Let me try again. Yeah, there we go. Always spacing out your work's always a way to go. All right, so we can find the length of the legs by saying, okay, I'm going to need to find the measure of the angle of the other two, but I've showed you how to do that in another one of these videos. Here we're going to say that's x degrees. And so I'm going to say 39 plus 2 of these x's is going to equal 180. So I could subtract 39 from 180, which is almost like subtracting 40 from 180. Okay, so it'll be 141. And then I'm going to say x is half of 141, which would be 70 and a half. Okay, so I know both of those angles down there are going to be 70.5 degrees. And so what I'm going to do is set up for law of sines. Say, all right, well, I'm interested in finding the length of the legs. I'll just call that y, I guess. And so I'll say, all right, law of sines. To find y. Okay, sine of 39 degrees divided by 425, that's going to be equal to the ratio of, sine of x, sine of 70.5 degrees, to y. And then I'm just going to do the normal law of sines thing, start solving for y. No, did not cross multiply properly. Y times the sine of 39 degrees is equal to 425 times the sine of 70.5 degrees. Then I could divide both sides by the sine of 39. Consult with a calculator, just like I've done in all these other ones. And see that those legs are going to need to have length 636.596. Okay, and that's going to be all the examples I got for you in this video. Law of sines is useful, it's a good one, but it's not quite as good as law of cosines, which is what I'm going to be showing you in the next video. So I encourage you to come back for that one. But for now, thanks for watching.